Hello again. We are going to be looking at section 11.1, talking about space figures and cross sections. We're looking at problem number 2 here on page 689 in your textbook. But before we actually got to 2, I wanted to bring your attention to this key concept, because that's what we're going to actually be using in problem 2. And that is, if you've got a three-dimensional space, or what we call a polyhedron, that the sum of the number of faces and the vertices of a polyhedron is 2 more than the number of its edges. So the formula, and Leonhard Euler, even though that looks like Euler, it's pronounced Euler, who was a Swiss mathematician, kind of came up with this little formula, that the faces plus the vertices is equal to the edges plus 2. Okay, so that's going to be really important formula that we're going to use in this particular section. So let me pull this down a little bit and let's look at problem number 2. In problem number 2 here, how many edges and faces and vertices does the polyhedron at the right have? And then use your results. So if you count the number of faces, you have a top, you have a bottom, and then you have 1, 2, 3, 4, 5, 6 sides. So that's going to make a total of 8 faces. If you count the number of vertices, vertices are the little corners where 2 lines come together. So you've got 1, 2, 3, 4, 5, 6 here, 7, 8, 9, 10, 11, 12 there. And so you can see that the number here is 12, and it's based on those vertices right there. And edges, again, is literally the number of straight sides that you have here. And you have 1, 2, 3, 4, 5, 6 on top. You would have, of course, 6 on bottom, so that makes a number of 12. Then you have 13, 14, 15, 16, 17, 18. So you're going to end up with 18 what we call edges. And you can see here, that's why it's marked here as 18. So we're just going to use the formula again that Euler gave us. And that is that the faces plus the vertices should equal the edges plus 2. And we're just trying to prove that this really is true. So remember, we had 8 faces and we had 12 vertices and we had 18 edges, and then the formula says plus 2. So I just filled in what I knew from each one of those. And 8 plus 12 is 20, as well as 18 plus 2 is also 20. So this verifies itself, or checks out as we call it. Okay. So let's look at a couple of the got it sections here. Now, if I had this one, since some of these have been given, remember it's faces plus the vertices equals the edges plus 2. So let's just fill in what we know. I don't know the faces this time because that's what's left blank right there. Okay, but I do know the vertices are 20, so I'm going to plug 20 in there. And I also know that the edges are 30, so I'm going to put a 30 in there. So really, what I'm saying, f plus 20 is equal to 32. If I subtract the 20 over, then I would find out that the number of faces is going to be 12. Okay? Same way works here. Again, faces plus the vertices equals the edges plus 2. Now, again, this time I'm looking for the edges. So I've got the faces, I've got the vertices, so 20 plus 12 equals E plus 2, because edges is what I don't know. Again, that comes out to be 32, which is just coincidental, equals E plus 2. If I subtract the 2 from both sides, then the edges comes out to be 30. Okay? So that must mean that there are 30 edges here, just like there were 12 faces here. Okay? And you can see that this is rearranged, but it's the same numbers. That's why we ended up with some of the same concepts here. I hope this helped. Best of luck.